Ready? Do you want me to start?
I start recording.
All right.
Oh, I already started
So,
recording.
oh, you did? Okay. So, our
Yep.
application that we want to make is called Help Hub, which is a real-time food bank web application. All right. So, in terms of our problem, the world faces a lot of challenges today, and charities exist mainly to help stop some of these issues, just to benefit society in a multitude of ways. So, in order to help aid these charities and help the common good, our plan is to develop a web application that benefits UF students that struggle to obtain food, whether it's through financial struggles or transportation problems, etc. So our problem is unique and it addresses a known issue in our community, which is food insecurity. So right now there's actually a food bank and we want to help that actual food bank. So our application will be able to track all the current food supplies through a local database. And right now there's no applications in the UF community that accomplish this task. So students can obtain access through real-time updates on food supplies by logging into the web application with their own UFID, and it will provide proper way for our application to verify if a student is a UF student or not. And students will be able to choose up to 5 items once a week, and this can filter out certain food groups depending on their own diet preferences.
So now I'm going to be talking about our project's languages and frameworks. But first, I'd like to provide some background information on the difference between front-end and back-end development. So front-end refers to the components of the website that the users see and interact with. And this includes things such as buttons and visuals, etc. Backend, on the other hand, refers to the underlying infrastructure and the data that allows the website to actually function. So for front-end development, the languages and frameworks we will use are HTML, CSS, JavaScript, and React. HTML is used to define the content of static or unchanging web pages. CSS is used to format the layout of web pages. JavaScript is used for dynamic or changing behavior, and React is a JavaScript library that allows us to implement these interactive components. Now, for backend development, we're choosing to use SQL or SQL as well as C++. SQL will be used to manage and update the database, and C++ will be used for any other operations that occur on the back end of development that won't be optimal to perform with SQL. And next we have our architectural design. So a software architecture model is essentially just a model that describes the structures of a software system and the process of developing it. In our case, that system is our website. Our architectural design is known as monolithic, as it comprises of single-tiered components that combine into a single platform. We chose this design because it's simple to test, simple to develop, and simple to deploy. Referencing the graphic on the right here, we can see that the user is at the top. In our case, this user is whoever is interacting with the website, whether it be a student, employee, or manager. At the top of the application itself is the user interface layer, which is the part of the website that the user sees and interacts with. In other words, this is the front end that I mentioned previously. Next is the business layer. The business layer contains the logic to determine the behavior of the application. The bottom layer is the data access layer, which allows for communication between the data and the website itself. And last, at the very bottom, we have the database, which contains all of the information, in this case, pertaining to the grocery inventory.
My name is Alex, and I'll be discussing the risk management that we have. So there are several risks that we take, such as insignificant risks, which have very little effect. We have tolerable risk, which delay our project, but we still can continue our project. We have serious risks, which have major delays, but there's still like manners in which we can finish the project. And there's catastrophic risk, which are risks that cause for the project to overall be unable to be completed. With these risks, there's different probabilities from very low, which are very unlikely to occur, to low, to moderate, to high, to very high, which are very likely to occur. Now, there are several risks on the developer side, like the examples listed above, right here. And these risks are like underestimated time of development, especially since we're taking several other courses. So this into consideration, we have strategies such as being able to focus on what is significant in a project so we maintain what we want to complete first so we can submit that in order to further develop the project if we have more time. There's also information we need that may not be there. So we have to have prior knowledge of what we're doing, allowing for the project to move on forward. And these risks have both serious effects, but the underestimation of time is moderate while the information is low for risk because most of these can be solved just with prior planning. Now, you as the stakeholder can also take risk since you guys have systems already in place. We can further make this easier for you guys to have lower risk when you guys take on this project is by making it easier for you guys to use by integrating it with your guys' software, overall leading to just lower risk for both us and you guys. Now moving on to user stories, inventory search filter. This is one user story, which is a way in which we can test like many various cases of views in our project. This one is, as a student, I am a vegan who likes to get certain food that is specific to my diet. Now, we are able to adhere to their demands by making a basic inventory search filter that will go through the whole database of all the foods. And since we sort them into categories, it allows for all the foods that they want to be shown without showing all the other unnecessary items that they may not be seeking for.
And hello, I'm Kevin. I'm the Scrum Master for this project. And then, so I'm going to continue on the user story. So this one I'm going to talk about is the student login. So basically the user story for this one is, as a student, I want to log in using my UFID so I can obtain access to the student view of the Help Hub application. And then of course, some of the features we have to implement are the unique, for the login, unique identifying username, or for the, in this case, the UFID. Then we also have to store the password chosen by this user. So then, so when they log in, it's like a unique user for each person. And then the next user story we have, or next user story is the ordering system, but specifically the employee view. So basically, the user story for this one is, as an employee, I want to be able to see the orders that I need to complete so I can fulfill orders in a timely fashion. So for this one, we're basically just showing the employees in the chronological order of the orders that they should fulfill. So like the stuff that the students order and the things that they have to put in each bag, and then print the thing and put the label for the order on each one. And then I'm going to go into the product backlog. So I'm just going to highlight some of the things that are in the product backlog. So we have login for students, update inventory, inventory search filter, then the ordering system. So the time estimate you see next to it are based off the Fibonacci series, and then they basically just give you like a somewhat of an understanding on how difficult the task is. So basically with one being the easiest one, so the login for students, and then we have the next difficult one, or I guess the second most easiest one. No, yeah, so we have 13, and then we have inventory search filter, and then the ordering system for the student. And then here's what we're gonna do for sprint one, the backlog for it. So we have to create the login for employees and the employees, students, and for the managers. So to accomplish this, we're gonna create the front end interface for the main menu, as well as a login sign up feature. And then on the back end, we're going to create Lambda functions using AWS to connect the front end to the backend database, and then to retrieve pull and get and post requests. And then we're also going to create tables in the database for the users, one for students, employees, and managers. And then for the capacity, it's basically how much work we're able to do per sprint. And the formula for that is group size times number of hours per week times 2 weeks. And then so we decide that we're going to put around 6 hours a week per person. So we get the capacity of 48 hours, but it also can be thought of as in story points. And then next we have velocity. So it's how much work needs to be done per sprint. And it's gonna be looked at in terms of story points per sprint. So then we calculate like for about 42 story points per sprint, including sprint one. And then next we have issues and next steps. So then one of the main issues we're looking at right now for a project is AWS requires payment for usage. So we might switch to another database like MongoDB or like MySQL. And then next we have to create the user login update feature, as well as inventory tracking and update inventory features after completing sprint one. And then that is all.
All right, very good. And so what I'm going to do now is I'm going to end